Hello and welcome to Miss Ma's Grade 11 Functions class. This is 8.4, Annuities. We're going to be talking about future value. So what is an annuity? An annuity is a series of investments or payments made at regular intervals. So you can think about something like a mortgage or something like that, or when you're trying to save money, sometimes you'll just put money in every month, try to put in the same amount of money in every month. That counts as an annuity. So it just works with a regular compound interest account, and we're making regular payments instead of just making one payment and then leaving it alone for 20, 30 years or whatever it is. Okay? So a simple ordinary annuity is the kind that we are going to be worried about. A simple annuity is one where the payments coincide with compounding periods, and an ordinary annuity is one made at the end of each interval. So if I'm compounding annually, I'm only putting money in once a year at the end of the year, simple ordinary end of the year, and once a year. And if it was monthly, then I'd pay at the end of every month. Daily, I'd pay at the end of every day, and so forth, okay? So let's jump right in. Example A, Miriam decides to invest $1,000 at the end of each year in a Canada savings bond earning 6.5% per annum compounded annually. Her first deposit will be on December 31st, 2015. How much will her investments be worth 10 years later on January the 1st, 2026? So you can see this is a regular account, and she's just putting money in at regular intervals. And that makes it an annuity, okay? So let's first of all split it into 10 pieces. And the reason I want to split it into 10 pieces is actually because every time she puts money in, that amount of money is going to earn a different amount of interest than any other time, right? So for example, when she puts it in at the end of year 10, it doesn't earn any interest. It's just $1,000, and it's just straight into her account. It doesn't sit there for a year, so it doesn't get to earn any interest, right? So that's $1,000. In the year 9, so in 2014, she puts in $1,000, and that sits in there for a year. So at the end of the term, it's actually worth 1,000 times 1.065, right? Because 0.065, that's the compound interest. So that is why she gets 1,000 times 1.065. In the year 8, she put in $1,000, and that actually earned 2 years worth of interest. So we're actually using the formula A equals P times 1 plus I to the n, and we're doing that with each of these years because they're all separate. So this ends up being 1,000 times 1.065 to the 2. And for year 7, again, we've gotten in there for 3 years, so it's 1,000 times 1.065 to the 3. You see? So as we go along, we can see that there's a pattern, and so we're going to add up all these numbers, and that is the amount that is going to be in the account, right? So if I go all the way down to year 1, that's actually going to have been sitting in the account for 1,000 times 1.065 to the 9 for 9 years, right? And of course, year 0, we don't contribute anything, so we don't have to worry about that amount because we are contributing at the end of every year. Okay? So you can actually see that this is a geometric series, and that we're multiplying by 1.065, right? So we start with 1,000 and we're adding all these together. So the amount in her account, that's called the FV, future value, is going to be 1,000 plus 1,000 times 1.065 plus 1,000 times 1.065 squared, and so forth, all the way up to 1,000 times 1.065 to the 9. So this is a geometric series. You can see it. It's pretty clear. So we have A is equal to 1,000, R is equal to 1.065, and N is actually equal to 10 because, of course, this is equal to A times R to the n minus 1. So we should have 9 is equal to n minus 1. N is equal to 10. So we're going to have to find the sum of the series S sub 10, and the formula for a geometric series is A times R to the n minus 1 over R minus 1. If we just fill in these numbers, we'll get 1,000 times 1.065 to the 10 minus 1 over 1.065 minus 1. So the answer, if we type that all into our calculator, is going to end up being $13,494.42. Now, this is a little bit of an annoying thing to have to, figure it out every single time and make this huge timeline. So, of course, we do want to find a formula for it. So basically, we notice that we're always going to have R, because that's the last payment is going to be worth R. The next one, the next last one that was made will be R times 1 plus I, and so forth, all the way to R times 1 plus I to the n minus 1, actually. Let me just add that 1 minus 1 in here. So FV is equal to the sum of the series, where A is equal to R, little r is equal to 1 plus I, and n is equal to n. So we'll notice, by the way, this R is going to be called our payment. This is our yearly payment, or annual, or annuity, the amount of our annuity. So if we plug these numbers in, A is R, so R times little r, 1 plus I to the n minus 1 over 1 plus I minus 1. If we simplify that down, we get 1 plus I minus 1 is equal to I, and we just move that R out to the front, and so the formula for FV is equal to R times 1 plus I to the n minus 1 over I. And this is one that actually we used to make people memorize, but we're going to be giving you this formula, so you don't need to memorize it. So on a test or on a quiz or on the exam, we will give you this formula, and you don't have to worry about memorizing it. Hooray! But you do have to be able to use it, so know where it comes from and know how to use it. Alright, so let's start using it. Donna wants to make monthly deposits into account that guarantees 9.6% per annum compounded monthly. She would like to have $500,000 in the account at the end of 30 years. How much should she deposit each month? So this is about saving money. And a reminder that we are talking about future value. Future value means how much will it be worth in the future. So with annuities, it's actually really important to think about whether the money is going to be a lot of money at the end, or is it going to be a lot of money in the beginning? If it's a lot of money in the beginning and we're going down to 0, that's actually present value. If we are going from 0 and we are saving up, then it will be future value. Okay, so and that's a really, really important distinction, and a lot of people find that confusing, and because of that they lose a lot of marks because they can't actually do the questions. So you got to watch out for that. So she's making monthly deposits into account. She would like to have $500,000 in the account at the end of 30 years. So we're going from 0 to $500,000. How much should she deposit each month? So we're trying to figure out what R is. So we're just going to use the formula. FV is equal to R times 1 plus I to the n minus 1 over I. And here FV is going to be $500,000, and we don't know what R is. We're compounding monthly, so it's going to be 1 plus 0.096 divided by 12 minus 1 in the top over 0.096 over 12. And this number is actually 0.008, so we're doing 500,000 times 0.008, which is 4,000, is equal to R times 1.008. Oops, I forgot to the n. The n is 30 years, and it's monthly, so 360 right there. To the 360 minus 1. Just always double check your work, because you never know if you made a mistake or whatever. So you type this into your calculator, 4,000 divided by 1.008 to the 360 minus 1. You'll get R is equal to $240.80. So Donna's payments, monthly payments, should be, sorry about the messy writing, should be $240.80. And there you go. Okay, we're going to do one more here. Nathan wants to save $95,000 to buy a cottage, and he is willing to contribute $750 every month to an account that earns 5.4% per annum compounded monthly. How long will it take for him to save the money to buy his cottage? So again, we're going from 0 to $95,000. We want to save that much money up, so we're not just getting a loan and then paying it off. So in this case, R is equal to 750, FV is equal to 95,000, and the interest is 0.054 divided by 12. If you type that into your calculator, you actually get 0.0045, so we could just use that number, or you can type that in if you like. And again, we're just going to write our formula out. FV equals R times 1 plus I to the n minus 1. Actually, I have a confession. I don't usually know this formula. It's just because I've been writing it a few times. So I haven't even memorized this formula properly. I had to review it. And there are a lot of calculators online that can help you to find these answers. So that's why we're not that concerned about you guys memorizing it, because when you get to the real world, most people don't actually know this formula. They just use computers. So that is why it's a little bit more practical to just memorize it, or just not memorize it, but have it at hand. It's easy to look up anyways. So we're going to solve for n here, so we do 95,000 times 0.0045, which according to my calculations is 427.5. And if I'm wrong, let me know in the comments, or you can let me know in class, because I do make calculation errors sometimes. So 427.5 divided by 750 actually ends up being 0.57, so that is 1.0045 to the n minus 1. So we're going to add 1 to the other side. 1.57 equals 1.0045 to the n. And of course, when we're solving for an exponent, we want to get one thing on this side and one thing on this side, and then we can use logs or we can use guess and check. It's up to you. I'm going to just use logs just because it's a little cleaner. So 1.57 equals n. And again, if you don't remember how to use logs, that's okay. Go ahead and use your guess and check. So n is equal to 100.46, and this is in months. So we do want to know how many years it is. Actually, do we? How long will it take for him to save the money to buy his college? Yeah, we want to know it in years, so we'll do 100.46 divided by 12, which ends up being 8.37. So 8 years. And 4 months. We'll say 5 months, because actually we need to make the extra payment, otherwise we will be short. So in 8 years and 5 months, Nathan can buy his cottage. That's not bad. So, and then hopefully he'll invite you all over for a party. Alright. So in summary, basically I just developed this formula. FV equals R times 1 plus I to the n minus 1 over I. And I was able to explain why, and you should be able to explain why too, although you don't really need to memorize the formula itself. And we use that formula to solve some questions. So I hope that helps. I will see you in class. Let me know if there are any problems or any questions. And thanks for watching. Bye!